Hello students, in this video I will be graphing absolute value functions. So let's take a look at the first situation here. You're asked to graph y is equal to absolute value of x. If you have no idea what something looks like, it is always a good idea to maybe perhaps reconstruct this. So as a first problem, I'm going in as if I have no idea what the shape of this graph is. So I'm going to make a quick chart here. So I have -2, -1, 0, and 1. Oh, and 2, of course. So if I substitute in these x values into that equation, what I will get is absolute value of -2, which is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So what I'm going to do now is I am going to graph this stuff out. So at -2, I notice that I have +2. At -1, I have +1. At 0, I have 0. And then at 1, I have 1. At 2, I have 2. And as you can see here, it forms this general shape. So this is actually the absolute value function when graphed, and this is the parent function, may I add. This is the parent function when we talk about the absolute value function. Just like what was the parent function for the quadratic? Well, it was just y equals x squared. So this is the most basic form of this type of equation. Well, let's take a look at the second scenario here. I have y is equal to absolute value of x plus 1. If I wanted to graph this, okay, I can actually try to attempt, well, actually, I can go through and once again apply this technique, although you're going to find in a moment that this can get tiresome really fast. So if I substitute in -2 into the absolute value equation there, I get -2 plus 1, which is -1. Absolute value of -1 is +1. Absolute value of -1 plus 1 is 0. Absolute value of 0 plus 1 is 1. Absolute value of 1 plus 1 is 2. Absolute value of 2 plus 1 is 3. So what I end up with is something like this. At -2, I have +1. At -1, I have 0. At 0, I have 1. At 1, I have 2. And at 2, I have 3. Just for the heck of it, right? Let's see what happens when I am at -3. -3 plus 1 is -2. Absolute value of -2 is +2. I will have another point over here, right? And if I do this again at -4, right, I am going to get +3. So it's going to be like that. So this is the absolute value of x plus 1. And pause for a moment, okay, if you can maybe make connections with what we did in the unit on quadratic equations, okay, or perhaps your understanding of transformations, okay. This what's the how is the graph in question 1? How does that compare with the graph in question 2? Well, if you notice, the graph was shifted to the left, right? So if we use function notation, and to denote this, let's say if y is equal to f of x, that's our parent function. If I have y is equal to f of x plus 1, right, this is going to be a shift in the left by 1 unit. So this is going to be left by 1 unit. All right, let's take a look at the third one. Now I have absolute value of x minus 1. Can you take a guess as to what will happen in here? Right? So if we're subtracting 1 from the parent function, that means all this is going to be, if we're doing this, we are going to be shifting down by 1 unit. So all the points, okay, that was originally in that V shape, it's going to look like this. Let's take a look at the next one. All right, now I have absolute value of x plus 3 minus 1. So see if you can figure out what this is. So the original, I want to graph the original in red. This is our parent function. Right? So what I'm doing here, the original absolute value function, what we're doing with this is we are adding h and then minus k here, right? So if you recall with the quadratic function, okay, what is this going to do? Right? The general form for transforming the quadratic function, right, it was f of x minus h plus k, remember that? Right? So in this case here, our h is really -3 and our k is -4. These numbers here actually give us the vertex, right? So the original vertex, okay, of the parent function was at 0, 0. The new vertex is now going to be at -3, -4, which is over here. And then all the points are going to be shifted in that direction. Right? So that's our vertex. This is -3, -4. Let's take a look at another scenario. Actually, before I get to this, let's do something simple. Instead of that, I want to erase this. So instead, we'll do this, just 2 absolute value of x. Okay, so 2 absolute value of x. Well, if our original, right, looked like this, what are we going to do with all the y coordinates? Again, this should be reminiscent of what happened when we were graphing quadratic equations, okay? There's going to be that vertical stretch that happens. There's going to be a vertical stretch. Right? All the y coordinates are going to be multiplied by 2. So in other words, what was at 1 is now at 2. What was at 2 is now at 4. Okay, so my new graph is going to look like this. What was at 3 is now going to be at 6. Okay, and so forth. So our graph ends up looking like this. There's going to be a vertical stretch. All right, so now notice that the original, right, the coefficient here in this case is -3, right? There will be a vertical stretch, but the entire graph will be flipped. So if we perform the necessary transformations, the vertical stretch is going to look like this, where all the coordinates are going to be flipped and stretched out, multiplied by 3, right? Or just think of it as multiplying by -3. And then we're going to be subtracting, we're going to be shifting this, right? Because I am subtracting a number from x and it's inside of the function there, this is going to be a horizontal shift to the right. We are going to be shifting this 4 units to the right. So what will become of this upside down absolute value function is the vertex in this case is going to be located at 4 comma, right? What's k in this case? It's going to be 0, where the y coordinate is 0. So the vertex is going to be 4 comma 0. And all the points gets shifted 4 units to the right. So that's our graph. Let's take a look at the next one. That was very similar. So let's do this guy. Yeah, let's do this guy, number 10. Okay, absolute value of -2 times x plus 4 minus 3. Okay, so again, what we're going to do is I am going to apply this vertical stretch first. So I'm going to do this in pieces. So the original parent function is going to have all the y coordinates multiplied by -2. So all the points gets multiplied by -2, all the y coordinates, that is. So that's my first transformation. The next is I want to take all these points and I am going to be shifting it 4 units to the left and then 3 units down. 4 units left, 3 units down. This is going to be my vertex. So it's -4, 3, -3. And my final graph will end up looking like this. Whoops. You can also get a sense of how this graph looks, okay, by punching this into the graphing calculator. So actually, let's take a moment and do that. So you can also come up with the graph of what we just did by entering -2. And to get the absolute value function, you're going to press Math. You're going to go over to the next tab there where it says Number. And the first option there, ABS, that's the absolute value. And I want to type in x plus 4 minus 3. And what I'm going to do is I am going to graph this with a standard zoom setting. And as you can see, all the y coordinates are in fact the same, right, as what we had come up with. If I press trace and I want to figure out, let's say, what is the y coordinate at -4, it should give me -3. If I wanted to figure out what the y coordinate is, let's say at -5, it should give me a y coordinate of -5, right? Which is exactly what we have over here, right? At -5 it is indeed at -5.